let's look at a potential solution to this challenge problem. So what we're going to do is we can either open up Visual Studio or Visual Studio Code. Let's work with Visual Studio Code because we show a lot of examples in Visual Studio. So if we go in, okay, so here what we're going to do is we need a new file. Let's make a new folder here. So this is pseudo random numbers in an array, right? So let's just call this challenge problem. Or maybe we could call it random array, something like that. Okay, so we'll call it that. I'll update that later. So now we're going to say open folder. Okay, we want to go up to the desktop, go random array, and select that folder. So we're going to create a C project here. So what we need to do, okay, we'll install the update a little bit later. So random array, we're in here. What we need to do is we need to generate the project, right? A C project for this. Okay, so to do that, go to View, Command Palette, or Control-Shift-P. Okay, and then you can start typing create C or C++ project. I have it here, create C or create C++ project. And what I'm going to do is I'm going to put it right in random array, say select folder. This is where we're going to create our project. Okay, and you can see that it's generated the folders that we need. This is where the executable is going to go. These are our headers, our includes. The interface is going to go there. Implementations go into source. Okay, so we don't, and we have a make file as well. Okay, and we'll see all of this, how all of this is generated, and talk about this in the labs, or we may have already seen this in the lab. So we're in source. Our main is going to be changed. We don't actually need this, so we can delete this. Okay, we have our includes. We don't have anything in here, but we're going to start producing things, right? So our goal is to first we need to generate a random array. Now we can do that in main. Okay, what we need to produce is we need to produce a function that looks through an array. Okay, we're going to give the starting index of that array to this function, and maybe its length, and this function is going to go through the array and look for repeated, okay, where the most repeats, okay, in that array occurs. The index of the set of repeats that occurs the most. So what we need to do is we need to make our interface for that function, okay, and we need to make our implementation for that function. Okay, so let's say we're going to create a function. Let's call it, let's go here, new file, and this is in the include section. So I'm going to call it find repeated location dot h. Okay, so that's that. Now if that is my interface, okay, I need to make an implementation. So new file, we're going to call it find rep location dot, now C or dot cpp, it doesn't really matter. We've been using dot cpp in you can run C code in C++, so there's no problem there. We have our main, which we cleared everything else. So we have basically our interface, our implementation, and then our client. Now our client, we're probably going to want to generate the random numbers within our client. So what we want, let's go here. We're going to make our interface. We need, so this one right here is what we can do. We can, the way we normally do things, space and then enter. You see how it gives us, and then we can close. We can close there. Okay, or just do that. Okay, so here what we have is the name of the file. Okay, and then this is going to be our interface, and this basically finds the starting index, right? That's the goal. We're going to be fed an array, and we need to find the starting index, right, of the most repeats in the array, right? Okay, so here, what do we need? We can put, by Michael, etc., and date or whatever we want to put here. We can put. Now I can take this and Control C and put that over here. And now instead of the interface, this is the implementation. So it's .c or .cpp. It doesn't really matter. You can use .c as well. And strictly speaking, .c is probably the best. But so this is the implementation. Okay, and we're going to start that here. So Control S, or you can save all is Control K plus S. Okay, but that doesn't matter. Okay, so the next thing, so we have that, and now we need our main. So this one is going to be, we'll leave it as main. This one is basically our client. So we go like this, space, and just keep going until we get to here. And then we'll say this is our mainline code, or main.cpp, let's say. Okay, and this is our mainline code, generates an array of random numbers, right? And calls the function. Okay, here, let me open this up a little bit. Okay, finds it to determine the location of the substring with the most repeats, or not string, but the of the set with the most repeats. How's that? Okay, and then here you can put your by. Okay, all right, and you can put date or whatever you like. Okay, Control S. Now here we have int main, right? We have main here. We don't yet know what we're doing. However, we do know that main returns something because it's an integer and it's going to return 0 in this case. Okay, so that's good. Now, what else do we know? We know that probably we need to get, we're going to need to generate random numbers. We're going to probably need some sort of input-output with the user. So the libraries that probably we need to include are, we need standard IO, right? .h. We need standard library probably. Usually this is just standard boilerplate. Include the standard library for data types and stuff like that. And then we're going to generate random numbers. They need to be seeded, right? So we need to include time. Time.h. Okay. And then we need to include our interface, right? That's the one thing. So include, what is it? It's, what did we call it? Find rep lock.h, right? Find rep lock.h, or locations.h. Okay, so these are the, let's see, I found it. Yep. Okay, so these are the things we need to do. Okay, and so next thing we need to do, what do we need to do first? There's a couple of things. One, well, we know we're going to generate random numbers, right? So seed the random number generator, right? So srand, and then we go time, and then we pass it null. Okay, and this we talked about in the lecture. Okay, the next thing we want to do is get, so we need to know the size of the array, right? So get size of array from user. So printf, okay, how many random numbers would you like to generate, and put in the array, question mark, and then go like this, and then we don't want a new line character here. Okay, next thing we want to do is get that information in from the user. So we're going to go scan f. Okay, if you're using Visual Studio, you might need to use the safe version, scanf_s. Okay, so here we're expecting an integer. Okay, and then we need to put it somewhere. We don't have a variable for that, so we should put a variable here. So we should say it's an unsigned. It can't be negative, so we'll make it unsigned, and we'll say number. And then we're going to say here, just put size of array of random numbers, right? Okay, so this is the size of the array. Unsigned, well, it's an unsigned int, basically. Okay, that makes more sense. Okay, so unsigned int number. So now we need to scan to that. So we need to go to address of number. This is just how scanf works, right? You have to give the address of where you want to write that number. Okay, so this is the address of this integer that we've declared. Okay, so that's that. So we've done that. What's next? So now what we need to do is we need to make an array. So now we know the size of the array. Now we need to allocate space for an array of that size. So let's do that. So allocate space for an array of size, well, it's number, right? And then we'll populate it too, right at the same time under here, and then populate it with random numbers, and they're from 0 to 9. 0 to 9. Okay. So now we need an array. Okay, so how does it work? We need malloc. We need to malloc. Okay, we need malloc somehow. Now, what's malloc? It's an array of, we want integers. Probably we can use integers, or we can use characters to save space. But okay, that's fine. We'll just say int. It's an array of what? It's an array of integers, but where malloc returns a pointer. So it's an integer pointer. And how many do we need? Well, we need number. That's how many integers we have. But how many bytes do we need? Times size of int, because we're using integers, right? So we need this many integers. Now we need to assign this to something. We need, okay, so malloc returns an integer pointer. So we need an integer pointer to point to the block. So what we need is we need int star. Okay, and this is the number, the random. We'll call it random number array. So this is a pointer to the random. This is pointer to first byte of, or first element actually, first element of the random number array. Okay, and that this gets generated when we malloc. So malloc. Okay, so let's do this. R number array. Okay, so this guy's a pointer, right? Our number array, our num array is a pointer. Okay, this guy's a pointer. Control S to save. Okay, so malloc returns a pointer. Has to be cast. Okay, because it doesn't know the size, right? So it's an integer pointer. Okay, so malloc returns, and malloc is looking for this many bytes of free space in the heap. Okay, this many integers, and this is how many bytes per integer, right? So this is how many bytes it's like. When it finds it, it returns it to here. Okay, now what I should really do for defensive programming is go here and say equals null, right? Okay, so right now it's null. Okay, and then if, right? If now our num array, okay, so if it's not null, then I can do something. Otherwise, else I could say fail to allocate space. Printf we could say failed to allocate space, right? And then so it failed to allocate the space for whatever. I could put it on a new line here just to keep it right. Okay, so we're doing some defensive style programming here. Okay, Control S to save, and this is what we're going to do, right? We want to allocate the space. All right, and then probably we need to. We're always going to need to free. Well, here we're going to free it anyway. Okay, let's just give a message for now that there was an error. Okay, and we can play with the rest of it later. Bigger problems, bigger fish to fry. Okay, so now if the array if a pointer was returned and it found space, then what we need to do is we need to start generating those random numbers and putting them in the array. So what we could do is go r num array. Okay, I'm going to use array notation for now. Equals rand. Okay. Mod something. Okay. Now, what are the number of random numbers that I want to generate? Do I want to go from 0 to 9 or 0 to 4? Now, what I'm going to do just for now is I'm going to go from 0 to 4. Okay, just so that I get more chance of getting repeats. Okay, so rand mod 5 is a way of getting a random number. Okay, so I need basically a loop of some sort. Okay, so that's what I need. I need to be able to go and add at each element. Okay, in this array, I need to be able to loop through, and I need to be able to find. To write to it, right? So, for now, I need an integer. This guy's an integer. I can put it here. Okay, so it's gonna start at 0. I equals 0. Okay, and I need to go, well, I is less than number, and then I plus plus. Okay, so this guy is here, and inside here, I'm going to populate this array with a random number between 0 and 4. Okay? And then here, what I'm going to do is I'm going to, as I populate it, I'm going to print it. Printf, we go %d, put a space, and then here we're going to put r num array at I. Okay, so that's how we're going to fill it. Okay. Okay, so let's do that first. Let's save this. What I have to remember before I close out. Okay. Before I close out of anything, I have to say if. Okay. R num array. Again, defensive. Okay. If r num array, capital N. Right? Then I'm going to free r num array. Okay? And Control S to save. Okay, so basically, I could even just put that in here. Could do that. Control X. Okay, put that here. And then I could set r num array equal to null, right? That's just defensive programming, right? We want to set it back to what it was. Okay, so that's good. We'll continue on here. This we don't need to put that much space. Okay, Control S to save. So this should print out those random numbers, and we can test whether or not it's generating what we want. Now let me go to Files, Save All is fine. I want to see the terminal. So let me see the terminal down here. I can use the bash terminal, no problem. Okay, so what I want to see is the output, right? So when I want to see this, if I want to run this program, what I need to do, I need to run make. right? So I'm going to go in here, say ls. I've got my source file in here. My include and make is there. So what I can do is I can say make clean. Again, you have to make sure that you have make installed. And then you just say make, and it'll compile everything. If there's no errors, it's telling me that there is an error somewhere. And it's saying find rep lock.h. There's an issue with that. What is it saying? It says fatal error, no such file or directory. Find rep lock.h. Okay, this could be it's looking in it must be with the make file. Is it looking in the right spot? Yeah, it has include. Should work. Just make sure that I have everything spelt right. Find, so include, find rep lock dot h. Okay, well, let me just see. Okay, let's just take this one out just for now. Okay, we'll see what's the issue there. Let's just run main by itself. Okay, so let's go and do that again. So go make clean, and then just make. Should have no issues here. Okay, and then we go cd src. No, not source. We need bin, and then let me see ls. What is it? It's main. So ./main should work. How many random numbers would you like to generate in the array? Let's say 10. And it generates 10 random numbers. So 3, 6, 9, 10. Okay, beautiful. So we're able to generate random numbers. Okay, so what do we have to do next in this in main? Okay, so once we've generated the random numbers, then what we need to do is we need to look through the array, right? So now we need to look through the array and look for repeats, right? So we need to call find rep lock and look in the array for the set with the most repeats. Okay, so what do we need? We need to know where to start in the array. Okay. Actually, no, let me stop for a second. I want to convert this from array notation into pointer notation. Okay? So what we need is we need to convert this. So this guy right here is equivalent to, so you have a plus I, and remember what I said, it's dereference. So what is located at that plus I. Our num array is a pointer to the first element, which is equivalent to this, right? And then here I can do the exact same thing. I can copy this, Control C, put that here, and now I'm using pointer notation. Okay, so let's go Control S to save. That's it. All right, so I just wanted to make sure that that part is clear too, because this is, and we can even test it. Control S. We can go in here. We go make clean. So wait a minute. I have to go cd ... I have to go make clean. Oops. Make clean. And then I want to go make. And then go cd bin. And then go ls. And then go ./main. How many random numbers? Let's go with 15. Generates 15. Okay, good. So everything works exactly as I thought it would, or as I expected to. So what I need to do, I need to start with, I need to find out where, I need to call and look for the spot in the array, the index in the array with the most repeats. So what I need is I need a variable that that tells me you know, what's the index. So what I'm going to do is I'm going to create a variable here and say start equals -1 as the index. So I'm going to make it an integer just for Okay, so this is the index with the most repeats of element or of set with the most of first element in the set with the most repeats. Okay, so we got that. So I'm just gonna I'm putting it at -1 as a it's a bad indicator, right? Okay, and then what do I have to do? Is I have to go here and I have to say that start is equal to find rep lock. Okay, now I have to give it, now this function I haven't defined yet, but what do I want it to do? I want to give it a pointer. Okay, so this is the pointer to the first element, and I need to give it the size of that array. Okay, so I have these two things. Now, I haven't defined this yet, but that's basically what I want it to do. And then I'm going to go in and I'm going to print f. Okay, and we're going to say the index of the \n index of the first element in the set with the most, I don't know, most repeats is, and then here we say it's an integer, right? Is %d, and then here we'll put maybe \n, and then we'll put start just to output that index. Okay, and then we can free it. We don't actually have to say if num_array here because it's already happening, right? Free our num_array. Okay, so we're good there, but we haven't defined this function. So let me go back here. We're gonna have to figure out what the issue is. So include find rep lock.h. Include find rep lock.h. Okay, there should be there. Okay, so now control save. Oh, save all is already there. So let's go into here. Find rep lock. Did I spell it right? .h. Okay, so in here, what do I have to do in find rep lock.h? I have to put the function prototype, right? So function prototype. This is the interface, so we need the function prototype. Sometimes maybe there's more than one later. And then I say int. Okay, now it's find rep lock. Okay, and in here okay, it's an integer pointer. It's a pointer to an integer, and I can just use my array, right? And then the next one is going to be the size of the array. So unsigned int, and I don't know, just size. How's that? Let's take this guy. Control C, so copy it. Now, usually what we do, so that if we ever have includes and they're included more than once, we basically put if-def blocks. I think I've shown this. I may have shown this before. So if not defined, and then you just pick you make a constant. Find rep lock. Okay, find rep lock. Okay, then if it's not defined, then we're going to define it here. Okay, find rep locations. Okay, and so basically this is only going to happen once, and now I put my end if here. Okay, so this block is only going to be executed once. Okay, because this can only be defined once. If it's not defined, it gets defined, and then these prototypes are only declared once. Okay, Control S to save. So now I take this. Now I have to do find rep lock dot cpp. Okay, go here, and what I'm going to do is I have to now I need to define, right? This is where I have my implementation. And what am I going to return? I'm going to return the starting index. So I need an index. I'm going to return something. So what I need is, so int, let's say start equals -1. Okay. So that's the starting index. Now what I need to do, I need to go through the array and look for how many. So what I have to do, I have to go through the array. When I see something that repeats, I have to have a counter for the number of repeats. But I also need another counter for the maximum number of repeats that I've seen so far, right? So I need two. I need repeats and max repeats. So I need int, I need repeats, and I'll initialize this. And then I need max repeats and initialize that to 0. So this is the index. I should really, it's not the, no, this is the index. This is the index of set with most repeats. And these two variables help us to determine which one, right? Number of repeats of current set. I should actually do this. Copy this up. Control X. Okay, and then we're going to have same thing here. We're going to say and max repeats. And this is going to be the same thing of the maximum of current max length set, something like that. Okay, so this is counting the maximum. And if repeats exceeds max repeats, then that becomes the new set. Okay, so what do we got to do? We got to search through the array. So we need some sort of integer counter. So int I, because we're going to go through the array. This is the for loop counter. So we're going to go for I equals 0. We're starting at index 0. I less than the size that was provided, right? And then I plus plus. Okay, and then we open up our. Okay, so now what do we need to do? We need to find out if there's repeats. So how do we know if there's a repeat? Well, we compare side by side. So if, okay, if our num array, okay, and we look at the next one at I plus 1, okay, is equal to, so we look at the next one and we compare to the one that we're on, our num array at I, okay, then what do we do? Then, so our num array, oh, it's actually, okay, so ours is not our num array, ours is, I'm going back to main, is just array, the array that we passed. Actually, you know what, let's just call it the same thing. So let's go into, you know what, it's okay. It's fine. We'll leave it at array. The array that we passed here is equal to the array that we passed here. Okay? I should really just call it R. I don't know if array is gonna be give me some issues. Okay, so like that. So if the side-by-side ones are the same, then my repeats, right, plus equals 1. Or we could increment, you say repeats plus 1, but that's the same thing. Now, if repeats, right, so if repeats is greater than max, we have it lowercase, max repeats, right? If that's the case, then, right, max repeats becomes, that is the one with the most repeats, right? Max repeats becomes repeats, and start is I. That new index, I, is the new index. Okay? So as soon as repeats is bigger, right? Then that becomes the new index. Okay? And start stores the location at the end of the repeated group. Now, this is the end. So start, in this case, okay? Look, start stores the location at the end of the repeated set. So what we're going to need to do, we need to subtract the size of that set to get the first element. Right? So we will need to, once we know the size of the set, we need to subtract once determined. Right? Once we get to the end of it, because we're not at it yet. Okay? Okay, so that's that. So that is the case there. Now, once we get through that, if they're not the same, else, okay, the current set of repeats equals 0, right? It has to be, you have to reset the number of repeats, right, for a given set. Okay, so that's fine. And then what we're going to do here is, what we need to do is, once we get to the end, right, start equals start minus the number of repeats minus. Okay, so start minus equals, okay, we need to take away max repeats. We need to take away max repeats. That won't get us to the first one. We got to go minus 1 to get to the, so the start index is the index of the last element, right? Minus the size of the size. But we started at 0. We added 1 for 2 repeats, so we have to subtract the 1 there, right? Start index is the last index, which is the last index in the set. So we have to subtract. So we have to subtract max repeats. To get the first one. And just notice that you know, when you have 2 repeats, this repeats shows 1, so you have to subtract 1 from that. Okay, so you don't subtract as much. Okay, so start is that. Let's we can test this one if we really want to. Okay, so that's return, and we're going to return start. Control S. Okay, so that should work. We can even test this one if we want to. Let's go and see what the issues are. So save all is done. What's the issue in main? Where's the issue? There seems to be an issue somewhere that it's showing us. Control S. Oh, no, nothing. Okay, let's see if we can compile this and see what happens here. There's something wrong with our include here. Possibly, I'm trying to figure out what the deal is. It could be our makefile, but let's test everything out and see. So let's go in here. So cd dot make clean, and then make, and we're probably going to hit an issue. I'm going to take a look and see what this issue is. Okay, let's try to do something else. Let's take these files. I'm going to create the new project, but I'm going to make it a .c. Okay, I'm going to make everything .c just to see if that's the issue. It seems like this. So I think what the issue is, this project generator, it has changed. It looks like there's an update that's been made to it. So what I'm going to do, just to make things nice and simple, I'm going to ensure that we're making a C project instead. So what we're going to do is we're going to go new, we'll say rand r, okay, and this will be the rand r2. Okay, so this will be the new project. What I'm going to do is I'm going to close out of this one. I want to close everything. I'm going to close out of everything, close the folder. and basically start from scratch. So I'm going to go open folder, random rand r2, select this guy, and I'm going to create a C project. I'm going to generate a new C project. So I want to go up here to here, command palette, and now we're going to create a C project instead. Here, select folder. Okay, let's go back here. What we need to do is take I need to copy into here. We'll go in random array, and what we're going to do is we're going to take everything from source. We're going to rename to main.c. Yes, I want to rename it. I want to rename this guy to .c. So we're going to do some debugging and see what our issue is. Yes. We're going to go into the include .h. That's good. Okay, so now what we can do is we can copy this guy into this one. So into the include, paste it there, and then we'll go to our source. We'll take these two, copy, and I should delete this guy. We don't want that one. And paste. Okay, so now we have that. Close out the old one. We should now be able to see this one here. We have, we'll call it .c, main.c. Okay, so let's see what happens if we try it now. So look at the make file. It's using GCC. Okay, good. And we'll open up the terminal. So new terminal. Terminal is going to be in this new directory. That's good. So we'll make clean, and then we'll see what the issue might be. Same issue. So we're gonna have to debug this a little bit more. Okay. Actually, if we look more closely, there's no issue. That's a different issue. It says that we're comparing assigned and unsigned. Oh, size versus, okay. I should be, let's go in here. So int I should make it unsigned because this guy is unsigned and I'm doing a comparison. So really this should be unsigned int, control S. Okay, that's fine. Let's see what else. Is there any other issue? Well, let's try it again. Let's go down to the terminal, say make clean, make. Okay, it's telling us now still no such file or directory. Find replications.h. Okay, let's take a look. Okay, so I can only conclude something is changed here. The way it's written, these include directories. Include directories should be included. So include, the C includes the -i, and then you have your include directories, and when you compile, you use the C includes. Yeah, this should work, but for some reason the include is not being included. So what I'm going to have to do is, okay, so this guy is in the source directory. So I'm going to go up from the source, out of the source directory, into the include directory, and then go to find replications.h. Control S. Okay, for some reason something has changed in the way that this compared to the way I've used it before. It looks like something has changed. Okay, so I've already tested this. So make clean, make, and it works. It compiled. For some reason, it wants a direct path to the header. It never did this before. So something has changed in the C project generator. Anyway, I'm going to save. And now we can go into cd bin, go into the binary file and type main. And it should give us an output. Let's see what's happening. Okay, how many random numbers would you like, in the array? Let's go with 15. Okay, and so any repeats? So far, this one right here. So this is, um, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm only generating 14 elements in my array. Okay, but it is the correct index. So this is 4, 8, 12. Oh, well, 15. Oh, I see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Index 12, 13, 14, 15. So it's correct. 15 elements. The 12th, the index is 12 here. Yeah, 13, 14. Yeah, correct. Everything is correct. Okay, so that's basically it. Let's try it one more time. Let's run it again. Let's go with 50 this time and see what happens. So we got more numbers. Smaller range, so index 44. I'm guessing that's this guy. So it should be 44, 45, 46, 47, 48, 49, right? 50 elements starting at 0. Yeah, everything works exactly as we had planned. Okay, so except for the hiccup of, for some reason, the C project generator in Windows wants the direct path to the file, the relative path from where the main file is when you do the includes. Okay, so keep that in mind if you're using Windows and you're using VS Code. All right, thanks for watching. I hope you enjoyed this video. Take care. Bye-bye.